हाँ, पर मैंने ये भी लिखा है कि सेकेंड हाफ ऑफ द क्लास सिर्फ 11 से 12 लिखा है. चलो भाई 11 से 12 नहीं, 10 से 11. Alright, so we start with this class. As usual, the slides are from CS230 written by deeplearning.ai, and now we go and talk about, so we'll quickly finish this and then, so what was IOU? See, what is the problem that was happening here? How many of you remember what we were doing? Object detection, okay, and in object detection what problems you can face? So we did two algorithms. What was the first one? First one was we were using sliding windows, right? So sliding windows was nothing but just, that was just a classification problem. You were just shifting that bounding box over the whole image in a hope that whenever there is an object, it will be detected in that window. What were the problems with that? So one thing is, if you are detecting images, one which is very small, another one which is very large, you will have issues there. That was more computationally expensive. The hyperparameter of the size of the window is a problem, okay? And then it was not that good anyway, because that was just classification in disguise, okay? So can anybody explain me this 3 cross 3 cross 8? Laptop lids down. Yes. Can anybody explain me this 3 cross 3 cross 8? Right. Very well done. Anything else? First of all, what is this 3 cross 3 cross 8? It is, these are the dimensions of what? In classifications, how did your targets look like? In classification, what were the targets looking like? Your target will be a, ये क्या कर रहे हो यार? In classification, when you are solving a classification problem, how will my targets look like? Right? A single vector. So the positive class will be 1, rest everything will be 0. Now this vector can be a 4-dimensional vector, this can be a 4000 dimensional vector, but this is how it will be, okay. Now what is this 3 cross 3 cross 8? So 3 cross 3 comes from that you are dividing your image into 3 cross 3 grid. Now for every grid, right, you have this kind of a thing. So what was the first thing? Probability whether there is an object in this or not. This is my bounding box and these are the classes. So if, what was the order of our pedestrian, car, motorcycle and then background, okay. So which of the 3 classes is there, right? Why we don't have background here? So PC equal to 0 basically means no object and hence just background, okay. Now, so this 8 comes from this. Now if I have 10 classes, what will this 8 become? If I have 10 classes, these 5 remain the same. So number of classes, they don't change this. You will have C1 from C1 to C10 you will have 15 here, okay, and so on. Now when I have an object there, it makes sense for me to output bounding box and the classes. What is this case? When there is no object, I don't really care what are these values, okay. But as you know, in practice you can't really have don't care. So there will be some numbers there, but you won't use them for any purpose, okay. Where is this part reflected? This part is reflected, if you remember, when we write the loss function, right? So when PC is equal to 1, you take that into account. Else, so when PC is 1, right, you take everything into account. When PC is 0, you don't take rest of the things into account except that first value, okay. All right. So is this fine with everyone now? What about this green one? So this green one is this object detected, yellow one here, so this one, okay. And then you are also giving bounding box for both of them, which is different from the grid cell. Earlier in sliding window, your bounding box will be same as the sliding window that is moving, but in this case now your grid is different from the bounding box, okay. Now one of the problems with the sliding window was you have to choose the right strides, because otherwise you can miss the objects, like it was happening in this case. There is no, this window that is capturing this particular object properly, even though there is a object. So you will have to really take small number of strides. Now in this case you are not taking strides at all. Every grid is responsible to detect the objects in it, okay. Questions here?
So either we will have the green one or the yellow one, then how will we detect two objects in one image?
Either you will have
yellow one or the green one as the output.
Right.
So how will we detect?
No, you won't have either of them. So look at the target output again. It is 3 cross 3 cross 8. So every grid will give you an object.
But grids are 9 and it is 8.
So 3 cross 3 cross 8. So for every grid you have this vector. So it is like this. You have 8. So 1, 2, 3, 4, 5, 6, 8. Okay. So this will be your, this first element will be your PC for this grid. Then you have 4 elements for the bounding box. Then you have 3 for C1, C2, C3. And you are doing this for every grid. So every grid will give you at most one object. So that issue is still there even with this algorithm that we are discussing right now. No grid cell can give you more than one object. We will solve this problem in the later. Now, so is this 3 cross 3 cross 8 over? See, this is one of the most tricky things in object detection. So let me know if this is not okay. Sorry? Right. So say that again.
Where is 9 here? We have 9 grids.
You have 9 grids, 3 cross 3. 3 cross 3. Yes.
So जैसे we have got to know that green और yellow में object है.
Right. Now algorithm is telling us, but anyway continue.
So now how we will come to know that this bounding box which is around the object is that part
How do we know that this bounding box which is
surrounding the object only? Like ये red वाला जो box है bounding box ये इस object पे कैसे detect होगा?
ये तो आप लोग बताओगे, कौन बताएगा भाई? Yes. नहीं, try any, देखो, whole of deep learning is a hack. So जो दिमाग में आ रहा है बोल दो. Most likely that will be right. Right? No. So sliding window has a problem, we know. Sliding window में either you take very less strides so that you don't miss anything. The moment you take this approach that you are going to take very less stride, it becomes so computationally expensive. I don't want to be doing that. Right? So we are not going back to sliding windows. Question? Huh? Question?
मतलब जो green और yellow box पे detect होगी कि इसके अंदर object है, but इसके बाद red वाला box कैसे detect होगा कि bounding box is object?
So this is a good question, not yours but mine. Yours is also good. Tell me whether we are at training stage right now or at test stage. Training. So if you are at training stage, who gives you this bounding box? Labeler. So this bounding box is already labeled. Can you repeat your question? So first of all, this box is not yet detected, this box is not yet detected. This is our target output and we are still preparing our data set. Okay? So right now I am not talking about inference time. I am talking about training time right now. But we will answer this question, your question in few minutes. Yes, more questions. Object detection is one of the most favorite topics of students' projects. Right? So you should be knowing this. Yes. More questions here? See, in my experience of teaching students, so I have been teaching deep learning since 2016. Okay? And my experience with students is that they don't struggle with codes. They struggle with these things. What is 3 cross 3 cross 8? Why it is 3 cross 3 cross 8? Right? They don't struggle with the code because if you are okay with Python, you will understand everything. Right? Try to do it. But problem is, you have to separate these two parts. Understand the theory, because all these frameworks, TensorFlow, PyTorch, they are so intuitive, you won't have problems there. Yes, but we'll cover PyTorch anyway. Yes. 3 cross 3 cross 8 is okay with everyone?
Yes.
Okay. Anybody who has a question there? Alright, so we continue. Now, so if I had one here, so I have 1 for PC equal to 1 here, PC equal to 1 here. What about PC for the rest of the grid cells? 0. Okay. So if for rest of the grid cells PC is equal to 0, what does it mean? Don't cares, right? So, but you are still computing those numbers anyway. So what is a good idea? Is it a good idea to have a lesser number of classes or more number of classes? So because see, you are doing all these computations here as well, right? But you are wasting whatever objects were there. So if you increase the number of objects, then every grid cell will recognize something, and so right now it will be heavy for us, but we'll change this later. Alright, so we continue. Now, what happens with this? So how do you specify a bounding box? We talked about this. Maybe you take this 0, 0, okay, and then start putting bounding boxes. If you make it specific to every grid cell, can you do that? You can do whatever you want, okay? There is nothing that stops you from doing that. All right, so this is fine. Now, why do we have this thing called intersection over union? Again, as I said, whole of deep learning is hack. आप जिस समय जो काम कर रहे थे, आपके जो दिमाग में आया, it will be easier to code, do it, right? Because all these papers that we are studying here, they were the first one to do something that was not done before. So YOLO, this version has so many problems, but you sideline the problems. Why? Because it enables you to do something which was not done before. So when you say there are issues with it, answer is yes. But the thing is, back in 2015 when they were doing this, nobody could do this, right? So why do we have this intersection over union now? So now let us talk a little bit about test time. What will happen test time in here? So let's say this, we have trained YOLO, and let's say we are testing it here now. So what will be my output at test time? At test time, what should be my output? What will be the size of my output dimensions? 3 cross 3 cross 8. I should have green one for that one. I should have yellow one for this one. Rest everyone 0 and some values, don't care. Okay. Now, most likely when you have a data set and you have hired some human labelers to do this labeling for you, each one of us sitting in this room will most likely come up with a different bounding box, right? Even though all of us will be making something very similar to this, probably these 4 numbers will not match, right? So we will have different bounding boxes for the same object in the same training data set. Any one of them, if I output, will that be a reasonable answer? Yes, it will be a reasonable answer unless the labeler was too uncareful at that particular moment, right? So all of these will be fine. At test time, what will you do? So at test time, if you have multiple bounding boxes, right? So the algorithm is looking at multiple bounding boxes for the same object. And there are other reasons too. So we'll come to that. So what is this intersection over union? So intersection over union is basically size of intersection divided by the size of union. Union means the area of the union of the two bounding boxes. Intersection, the one that is common. Okay. So correct if IOU is greater than 0.5. You decide this threshold. Okay. What do you mean by correct? So let's say this is my bounding box that labeler gave me in my training. Okay. And at test time, I happen to output this one. If I don't output this one, and if I say output this one and I say there is a car in this, is this bounding box correct one? No, right? So how do you decide this, yes or no? If the intersection over union is greater than a threshold, that you decide. Of course, this must have increased in today's world, because in today's world it's been 10 years since this YOLO version, right? And a lot of things have improved. Any questions here? Okay. So all you do this is just to decide that you compare it with your original whatever bounding box and see whether this one that you are inferring is in some sense right or not. Questions here? Now we come to non-max suppression. So if you have, so as YOLO does, YOLO takes an image and fragments into 19 cross 19 grid, not 3 cross 3, 19 cross 19. Okay. Let's say we are continuing with our example of how many classes? 3 classes and 1 background. Okay. So tell me, how will my output look like? I mean target output. 19 cross 19 cross 8. Okay. So I can make how many bounding boxes just for this particular image? How many bounding boxes for this image? Yes. Bounding boxes can be infinite, right? कहाँ से लाते हो यार? ये bounding boxes. These are the coordinates of one bounding box. अब infinite कहाँ से ला रहे हो? Yes, anybody? 19 cross 19, excellent. So you will have, so see, every grid cell will give you one bounding box. So we are still having this problem of every grid cell giving me only one. But if I break this thing into 3 cross 3 versus 19 cross 19, which one will be able to detect more objects? 19 cross 19, right? So even if let's say there were more objects here now, okay, because and why so? Why so? Why 19 cross 19 will detect more objects compared to 3 cross 3 in general? Because my grid cell gives, so in a limiting case, if I divide my grid into just 1 cross 1, I can detect how many objects? Just one. Okay. If you in the other extreme, every pixel belongs to a class, you will be able to detect all the objects possible. Okay. We are somewhere in between. Your grid is not 3 cross 3, not 1 cross 1, not n cross n, it is 19 cross 19. Okay. So every grid cell will give you some object. What is the problem with this? Maybe this gives you some hints. Can you have multiple bounding boxes for the same object? Why? So one labeler gives me this bounding box whose center is here. Another one gives me this bounding box whose center is say here, and so on. Are all of these right bounding boxes? Yes, but because my grid size is so small now that even this grid can claim an object, this grid can claim an object, and let's say even this one claims an object, but all these three objects are the same objects. Okay, how do we take care of this? Yes, is the problem clear? Multiple grid cells can say I have detected an object, and it could be the same one that neighboring cells are detecting. How do we take care of this? And same here, exact same argument here, so I am not repeating that here, okay? Huh? Multiple grid cells? No. So if my 3 grid cells are detecting the same object, I need to get rid of this redundancy. How do I do that? As I said so many times before, deep learning is a hack. जो दिमाग में आए बोल दो. And keep intersection over union in your mind. When I will tell you, you will say it was so easy. Literally the first thing that comes to your mind is the answer.
सर लाइक जो लेफ्ट वाली कार को डिटेक्ट करते हैं सारे बाउंडिंग बॉक्सेस उन सब में 010 जो क्लास है वो सी क्लासिफाई होगी
Right.
तो उन सब का जो कोऑर्डिनेट्स है उनका मिनिमम और मैक्सिमम लिया और फिर वो एक बाउंडिंग बॉक्स बनानी है
Minimum or maximum? I did not understand.
कोऑर्डिनेट्स में से मिनिमम लिया तो सबसे लेफ्ट वाला सिलेक्ट होगा left
Okay.
coordinate, और मैक्सिमम लिया तो राइट वाला तो उससे बाउंडिंग बॉक्स
So what you are saying is you are making a bounding box that is in some sense union of all the bounding boxes. So that will work, but can you do better? Yes. Intersection over union is equal to 1. Will that ever happen? But you are on the right track. Intersection over union will be 1 in which case? When it is the same bounding box that we are talking about. But we have talked about that no 2 labelers will give me the same bounding box. That is what I should assume. I should not assume they will give me the same. If they give me the same, this is good. But I need to assume my worst case that no 2 labelers or a lot of labelers are giving me a lot of potentially different bounding boxes. But of course, all are bounding boxes here. So no labeler will do this for this bounding box. Okay? Easy. So if we combine your answer and your answer, maybe we'll get the right answer. Now can you tell me?
Take IOU with greater than 0.5.
Sorry?
IOU where is 0.5 written.
Right. So now we talked about IOU. So in this case they have kept the threshold 0.5. Now, so I have these 3, let's talk about these 3 bounding boxes. Okay. Now, so 3 bounding boxes, how will you decide which one I am going for? Which one is the most confident of the object? So PC is equal to highest for this bounding box, 0.91. Okay. But I have other bounding boxes with good enough PC, 0.7 and 0.6. What do? I compute IOU with this guy. Okay. So this is the algorithm. Each output prediction is this. Discard all boxes that have PC equal to 0.6. Okay. So if a grid cell is not confident enough where the threshold that you are putting is 0.6. So any grid cell that says that detects an object with probability less than 0.6, we discard. So a lot less will remain now. While there are any remaining boxes, if there are no remaining boxes, then you are done. So while there are any remaining boxes, pick the box with the largest PC output as the prediction. Okay. Discard, but you can still have, like in this case, you have 3 bounding boxes with PC greater than or equal to 0.6 and they are all detecting the same object. So discard any remaining box with a IOU 0.5 with the box output in the previous step and you are done. Will this detect all objects for you? Is this foolproof? Obviously not. but you don't have to look for its problems right now. Again I repeat, this was the first algorithm that was able to do it computationally efficiently, and the efficiency was much greater in terms of object detection. So this will have its own problems, there will be issues that you can raise, but this is what the YOLO in first, second and third version did. Questions here? Simple thing, those grid cells, so I will keep only those bounding boxes for which output PC was greater than 0.6. Now in case you have now compute IOU, so take this 0.91, take this 0.91, okay, compute IOU with these two boxes, right, and those that have IOU greater than 0.5 with the box, you discard them because most likely they are detecting the same object. Again we say most likely. Will you miss some things? Of course you will. Can you generate a case? Can you generate a case where whatever we have done until now will fail? And it's easy to do so. So there is yet another car here. There is yet another car here such that, you know, so let's say this is the center of one car and this is the center of other car. Now in this case you might end up giving up on one car because IOU will certainly be greater than 0.5. So let's say for one, let's say for this grid PC is 0.9, for this PC is 0.92. When you will take the IOU for these two, you will take 0.92 and discard 0.9. So if two objects are close enough, we are not there yet. Okay. Any questions? Any questions, because we are done with the base version of YOLO, YOLO 1, 2, 3 at least. Yes.
सर इसमें वो प्रॉब्लम कैसे सॉल्व हुई कि मल्टीपल ग्रेड सेम ऑब्जेक्ट के ऑब्जेक्ट को बिलोंग करते हैं
Multiple grades. Can anybody help me answer this? Multiple grades, same object. So this is the case you are talking about. And how did we solve this? Discard all the bounding boxes with PC lesser than 0.6 and I am remaining with these three. Now compute, so now you are going to output this one, but wait, there are other guys as well. Compute IOU with this guy and rest of the one. If IOU is greater than 0.5, you discard this, you discard this. More questions here? Done? Sure. Now, anchor boxes. So, as I said before, all these are hex. So, let me ask you this question. How will you solve this problem of, so let me just give you this. What problem is this solving? In the same grid you have two objects. So center of two objects, this car and pedestrian both. So you have two classes in the same grid cell and for everywhere else you have PC equal to 0. So let's discard everything because this is our, how do I solve this problem? Again hack. So not hack JKLU. Yes. Look at this Y. Look at this Y, this should be able to help you. So right now we are talking about two anchor boxes. Anchor boxes, they give you some special shape, right? So anchor box 1 will always be, of this shape, lesser width and very long. This guy, width but not so long. So you have decided these two anchor boxes beforehand. What is this guy? PC. There is an object in this or not? This guy? Bounding box, class. So this is my same 8 numbers. PC, bounding box, and then 3 classes. Can you tell me what is here? So now, if I have 2 bounding boxes, how will my target output look like for this particular image? Three cross 2 cross 8. Okay. Right? Yes. Is this fine? Okay. If I have 5 anchor boxes, 3 cross 3 cross 5 cross 8. Okay. But having 5 anchor boxes is really difficult. Why? I could think of 2 shapes, one is elongated, one is wide. Maybe you can think of one square, okay? Well, no, that will make your life hard, right? So right now we are keeping our life simple, because otherwise you can come up with something circular. We are not doing such things right now. Right now we are taking good rectangles without tilting at any angle with this grid, okay? Alright, so now tell me, how many objects can this particular algorithm detect in this whole image or in one grid cell? Now in one grid cell, which part will detect the pedestrian? Anchor box 1. And anchor box 2 is supposed to detect the car. If I have 5 anchor boxes, then so let's say there is yet another one with a square thing, go ahead with that. You have yet another thing with smaller square, do whatever, okay. Okay, so previously each object in training image is assigned to grid cell that contains that object's midpoint. Output was 3 cross 3 cross 8. With 2 anchor boxes, each object in the training image is assigned to grid cells that contains object's midpoint and anchor box for the grid cell with highest IOU. Okay. So you have grid cell and anchor box. So output will be 3 cross 3 cross 16, which is 3 cross 3 cross 2 cross 8. If you have 5 anchor boxes, it will be 3 cross 3 cross 5 cross 8. So let's reread this. Each object in training image is assigned to a grid cell, यहाँ तक ठीक है fine, that contains object's midpoint and anchor box for the grid cell with highest IOU. What about, I don't understand this thing. Right. So that contains object's midpoint and anchor box for the grid cell with highest IOU. Chalo, let's do it here. So anchor box 1, anchor box 2. In fact, this is the same thing that we have already done in that slide before. How do you explain me this? Object is there, bounding box, class, pedestrian is there, pedestrian hai na bhai, one, pedestrian, car and motorcycle. So pedestrian, and then this one for the car. Okay, where is IOU coming into picture? Think over it.
Sir, those grid cell will be included which have IO greater than 0.5. Like
Because otherwise what will happen?
because there will be multiple grid cells associated with one object.
There will be multiple grid cells associated with
One object.
one object, right?
So we will only consider those grid cells that have IO more than 0.5.
Okay. Right. So explain me this one as well then. Is it possible to have a grid cell which detects only one object? Yes, right? So in this case, anchor box 1, so there is no pedestrian but only car. Now putting it together, I think you have everything now. I don't really need to explain this. So training Y is 3 cross 3 cross 2 cross 8. See, this is the most complicated part of object detection. Your targets are becoming so complex, okay, and so tedious to label. So 3 cross 28, but YOLO divides every image into 19 cross 19. So that will actually be 19 cross 19 cross 2 cross 8. If you have 5 anchor boxes, 19 cross 19 cross 5 cross 8, which is 40 here, and you know the rest.
सर
Yes.
सर इस जो इमेज है जो गिवन है इसमें 3 + 3 + 2 क्रॉस 8 क्यों लिया? इसमें तो क्रॉस 8 है या जनरल?
See, once you have embedded anchor boxes in your training, right? So for example, 1, 2, 3, 4, 5, 6, 7, 8. For all 8 grid cells, this will be 0, this will be 0, rest will be don't care, right? This puts a lot of computational overhead on you, but it allows you to detect more than one object in a single grid cell. So you decide for your application whether detecting multiple objects in the same grid cell is more important. If it is yes, go ahead with this. If you think no, my objects are sparse enough, right, there will be hardly a case in which I will have 2 objects in the same grid, don't use anchor boxes, use the previous one. Because by using anchor boxes, you are just increasing these guys a lot. For this example, if you have a lot of classes, then yes, you won't have these don't cares as many. So for example, in this case, if you also have trees as object, this guy will say something, okay, and can I say this guy will also say something? Yes, trees are there, trees are here, but let's say snow is also there, then snow as well, okay, and so on. Things become complicated, yes. Now making predictions. So I want to finish object detection today, so let's do it and then we'll take a break. Or maybe let's take a break and then when we come back. So I have to take attendance first up.